might not, be able to contact people, survey people who do not have cars. And using the third method, you might not be able to contact people, reach out people who, you know, do not intend to vote and therefore are not registered. Okay, so that's what we mean by, how we frame a population, right? How we set up the sampling frame, how we choose the sampling frame has a huge effect on our possible survey results. That's why in many surveys, people would tend to use multiple, sampling frame to cross-check, right? So that, they don't miss too many people or their results are not too biased. Okay? So this is the first very important consideration that you should have when you select your samples. All right, so even with, all these, very concrete versions of your population, there's another issue that random sampling almost always encounter, and that is the issue of over and under representation. Okay, and this is one of the reasons that we say that your sample might not be representative of your population, because you might have over or underrepresent a certain segment of the population. And by that we mean, we can always divide people into different categories, right? Based on their gender, based on their occupation, based on their religious affiliation, based on their party affiliation, whatever, right? There are countless dimensions along which you can divide people into. So when you are doing the survey, right, there's always a chance that you do not faithfully, right, not intentionally, but you're just not being able to make your sample exactly look like your population in terms of the composition of all these categories. So one major issue, as we said, is over and underrepresentation, and under or overrepresenting a particular category would occur when, for example, the relative proportion between the segments in the population, right, is not accurately reflected in a sample, right? So this is the definition of over and underrepresentation. In other words, the segments, the proportion, the relative proportions between the segments, between men and women, for example, between blacks and whites, for example, between uh, Catholics and Buddhists, right? The proportions are not right in the sample. So whenever that happens, you might have run into the problem of over or underrepresentation. So overrepresentation then simply is that what you observe, right, in terms of the proportion of a segment, let's say men, right, in a sample is larger than the actual proportion of men in the population, right? In a sample, you observe that you have 20% of men, but what if in the population the proportion of men is only 18%, right? So compared to 18% of men in the population, your sample includes 20% of men. That's overrepresentation. Okay. Conversely, then, you might have underrepresentations, right? So in the population, you might have 20% of men, but in a sample, you might have 18%, right, of men. So in that case, right, let's say, in the population, you have 20% of men, but in the sample, you only have 18%, right? So in this case, the proportion in the sample is smaller than the proportion in the population, and when that happens, you have a problem of underrepresentation, right? And under and overrepresentation will occur because whenever you're selecting a subset of individuals from a population, there's always this chance factor that might bias your observation, right? You have, for example, right, let's say, in this population, you have, let's say, 3 triangles and 4 squares. That's, or 5 triangles. How about that? Right? You have 5 triangles and 4 squares. So if you sample, when you sample this population, and if your sample is truly random, right, then you might end up with a sample that has, for example, 2 squares and 3 triangles. Okay, so the proportions are not exactly identical, but it's very close, right? You have 4 squares and then you have 5 triangles. So if you divide, if you only select 2 of them, right, that is half of the squares, you will also select half of the triangles, and half of 5 is about 3. It can be 2, it can be 3, but technically it's 2.5, but we don't have half of a triangle here. So it could be 3, right? So it's close enough. But what I mean here is you could probably end up with a sample just because you choose everything randomly from this population. You have 1, 2, 3, 4, 5 elements here, right? So in here, the 5 elements are nicely divided between triangles and squares. But because of chance, you could easily end up with all 5 elements being the triangles. That's just how lucky you are, right? So in this case, this sample obviously overrepresents triangles, right? Because here you don't have any squares. You might think, aha, well, the population only consists of triangles, which of course is not true, right? You're underrepresenting squares in the sample, and you're overrepresenting triangles here, right? So that's the problem, right? That's the problem of over and underrepresentation. So let's see if we truly understand the idea. So assume in the population, the ratio between male and female is 1.2 compared to 1. That means for every 1 female, you will observe 1.2 males. Okay? Okay, so this is the true proportion, right? The expected proportion in the population. Now, Andrew draws a sample, and he observed that in the population, in his sample, he has 120 men and 80 women. My question here is, which gender is overrepresented? In other words, another related question will be, which gender is underrepresented? What do you think? How would you solve this problem? I give you 2 seconds to think about it. Okay. How do we solve this problem? Okay, there are many ways actually to solve this problem, to answer this question. The most easiest way is to look at this. It so happens the numbers are arranged in a very interesting manner. That is, if you look at this, right, gender ratio in the population is 1.2 versus 1. You will see that 1.2 is very similar to 120. In fact, if you divide 120 by 100, right, you would exactly have 1.2, right? 120 divided by 10, that gives you 12. But then if you divide 12 by another 10, you get 1.2, right? That's just to say, if you divide 120 by 100, you have 1.2. So now you have divided 120 by 100. Then you will do the same, right, to divide 80 by 100. So what is 80 divided by 100? That gives you 0.8 or 0.8. So now you see the true population, true gender ratio in the population is 1.2 versus 1, but in Andrew's sample, the ratio is 1.2 versus 0.08. Now, which gender is, well, underrepresented? What do you think? Women. Okay? Because in the population, for every 1.2 men or males, there will be one female. But here in Andrew's sample, for every 1.2 males, there's only 0.8 female, not even one. In this case, females are underrepresented. Okay? In other words, because this population, the sample only consists of two segments. So if one segment is underrepresented, it follows that the other segment is overrepresented. Right? So the answer to this question is men is overrepresented. So that's one way to solve this problem. There's another way to solve this problem. That is, you convert 80 to 1, because here female is 1, right, in the population. So how do we convert 80 to 1? What do we divide 80 by so that we have 1? Well, you divide 80 by itself, right? 80 divided by 80, that gives you 1. Fantastic. Now we have one match here. So if you divide 80 by 80, well, divide the number of women by 80, you will similarly divide 120 by 80. So what is 120 divided by 80? Right? So you can start to press your phone, and the answer is 1.5. 120 divided by 80 gives you 1.5. So in other words, for every one woman or female in Andrew's sample, you will see 1.5 males, which is larger than 1.2. So again, the answer is men are overrepresented. The ratio is 1.5 to 1. Okay, you get the idea, right? So the question, of course, is then, how do we avoid over and under representation when we perform the sampling? Solution is, of course, to sample based on according to the relative proportions. That is, you sample however many men and women based on the gender ratio in the population. Okay, so the procedure is, first of all, you divide populations into smaller non-overlapping groups. We call them strata, For example, in our case, one stratum will be men, another stratum will be women, right? So men and women are two strata in the population, right? We divide a population into two strata, one being men, one being women, for example. The second step is to determine what should be the size for each strata? How many men and how many women should we draw from the population? Right? Last step is easy. That is, we'll randomly select individuals from the population till we have a set amount of men and have a set amount of women. Okay, so let me repeat. The procedure to sample based on relative proportion is to, first of all, divide the population into smaller strata, right? Based on, of course, the goal of your study, right? In this case, we're talking about gender proportion. So we divide the population into men versus women. And then we determine how many men and how many women we need based on the population information, right? And of course, based on how many people in total you would like to sample. And then you will randomly sample individuals from your population till you have selected the predetermined amount of men and a predetermined amount of women. And we call this stratified sampling, right? Because we're sampling based on strata. So imagine a population, and we know this population has a gender ratio of 1.2 to 1, right? For every one female, we have 1.2 males. So now Andrew has, or would like to draw a sample of 200 from this population. From this population that is with a gender ratio of 1.2 to 1. So the question is, how many men and how many women should Andrew draw from the population? How do we solve this problem? Right? So if you would like to solve this problem by yourself, then you should probably click pause and then to work on your own and then compare your steps with mine. But if at this stage you're simply overwhelmed and would like to see, how I solve this problem, then you're welcome to watch on. Okay, so step one to solve this question is to find the ratio of men over the entire population. What you have here, or what we have here, is men versus women. But now, our samples, this size is for the entire sample, is not for women, right? So if 200 is women here, then the amount of men we need will be very simple, which is time 200 with 1.2. That will give us 240 men, right? So if 200 is the number of women, but 200 here is not the number of women. Instead, it's the number of the total sample size, and that's why we need the ratio of men over the entire population. Okay. And how do we do that? We have for every one individual, we have 1.2 men. Sorry, for every one female, we have 1.2 males. That suggests the proportion of men over the entire population should be 1.2, with 1.2 here. The entire population equals men plus women, therefore 1.2 plus 1. Okay, so in other words, the ratio of men over the entire population will be 1.2 over the sum of 1.2 plus 1 will be 1.2 over 2.2. Okay, and then the next step will be very easy. You simply multiply the ratio with the sample size, right? So for every 2.2 people, you will have 1.2 men. What if now you have 200 people? How many men should there be? You time 200 with 1.2 over 2.2. That will give you roughly 1.9 sorry, 109.1, and that's roughly 109 individuals. So this amount is the target sample size of men, right? So now you should draw, or Andrew should draw 1.9 men for his sample. And of course, very simply, because the sample only consists of men and women, now you have 1.9 men. Very easily, you should be able to solve how many women you should obtain, right? So it will be 200 minus 109. That will give you 91 women. We can verify this, right, to see whether or not 1.9 versus 91 is a ratio that's very close to 1.2 versus 1. We can do that by, first of all, dividing 109 by 91. Fantastic, right? So if you divide 109 by 91, that will give you 1.197. That is very, very close to 1.2, right? 9, if I round it up, right, it will give you 1.2. See, 1.2. And of course, if you divide 91 by 91, that is female by itself, that will give you 1. So 1.2 versus 1. So there we go. 109 is the correct answer, right? Given this ratio in the population, and given that Andrew would like to sample 200 people, Andrew should draw about 109 men in the sample. Okay, so in this case, we solve the amount of women in our sample the easy way, right? Because we know how many we should draw for men. We'll simply, subtract the amount of men from the entire sample size. We got, the sample size of women. But what if I ask you to solve for this number using these two steps, right? How would you do it, right? Using, in other words, these two pieces of information, how would you proceed in order to have the same answer, 91? Try it by yourself. Okay? Okay. So if you would like to try it by yourself, you should pause. But otherwise, I would just, go ahead and describe the step for you so that, we don't waste video clip time. All right, so they're similar, right, as to how we solve for the number of men that we need. So we'll just, see that, hey, for every one woman, we'll have 1.2 men. And because the population consists of men and women, so again, the entire population will be 1.2 plus 1, and that's 2.2, right? Okay, now you will see, all right, so this is the entire population, which is the same thing here. Then what should be the numerator, right? This is the denominator. What should be the numerator here? Well, when we're asking how many men we should draw, we use 1.2, which is men's ratio. Now we're asking how many women we should draw, so that means we should use women's ratio, which is 1, right? So it would be 1 over 2.2. That means for every 2.2 people in the population, we should observe 1 woman. Okay? Now the question is, what if we need 200 people? Then how many women do we have, right? So if we use 200 to multiply this, what do you call it? I don't know the name, the English name for this expression, But I assume you know how to operate here, right? So it's 200 times 1 divided by 2.2, right? So now you will see, you will use your calculator to see what is the answer of 200 divided by 2.2. That is 90.90. If we round things up, that will give us 91. Fantastic. Now we have exactly the same answer by using a different method. Okay, so I hope you will understand this reasoning here, this process here, because you bet we'll have exam questions like that, like this in our second examination. Okay, all right, so originally I say, repeat the procedure for women, but now, what you should do is really you should repeat the procedure for both men and women till you understand the reasoning behind. Okay? Now, let's see. What if we have a more complicated situation? That is, instead of having 2 strata, now we have 3 strata. That is, in a population, imagine, we have the ratio between the 3 party identifiers as 2.5 versus 1.5 versus 1. That is, for every one individual independence, there will be 1.5 Democrats and 2.5 Republicans. So now the goal is to draw a sample of 100 using stratified sampling. The question is, how many Republicans, how many Democrats, and how many independents should be included in a sample so that the proportion of Republicans, Democrats, independents will be highly similar, if not identical, to the proportion of these party identifiers in the population. At the same time, the numbers for Republicans, Democrats, and independents in the sample should add up to 800. How do we do that? Okay, so if you understand the previous exercise, right, then this exercise will be just, an extra step. The basic reasoning is the same. So let's solve this together. Oh yeah. So we have 2.5, 1.5, and 1. That means, this population has 3 segments, and in total, right, we should have 2.5 plus 1.5 plus, plus 1, which have this many people, in terms of ratio, right, in the population. And what is 2.5 plus 1.5 plus 1? So there's Republicans, Democrats, Independents. We add them together, we have the entire population, right? So 2.5 plus 1.5, that gives us 4, and 4 plus 1, that's 5. Okay, so that suggests for every 5 people, we should have 2.5 Republicans. So for every 5 people, we should have 2.5. For every 5 people, we should have 2.5 Republicans. And our goal is to have 100 individuals. That should give us 50. Because 2.5 exactly is half of 5. So here is 1, and here will be 2, right? So the half of 100 is 50. Now, how many Democrats do we have? So for every 5 people, we should have 1.5 Democrats. And now we have 100 people. So that will be, this will be 20, right? If we divide 100 by 5, that will give us 20, and 20 times 1.5, that will give us 30. Okay. Lastly, For every 5 people, we'll have 1 independent. Now we have 100 people. So 100 times 1 divided by 5, 20. 20 plus 30 is 50. 50 plus 50, that's exactly 100. Fantastic. Okay, so here's the solution, right? Just to repeat, oops, what I'm doing here. Just to repeat what damn it. Just repeat what I said here. Republicans, we need 50. Democrats, we need 30. Independents, we need 20. Okay, so this is how many Republicans, Democrats, and independents we need in our sample so that we don't overrepresent or underrepresent each of these segments. Because if you transform these numbers to the ratios are exactly 2.5 versus 1.5 versus 1. To verify, we first of all, right, divide 20 by 20. That will give us 1. That's independence. Now, what is 30 divided by 20? Exactly 1.5. What is 50 divided by 20? That's exactly 2.5. So once the ratio, right, of the segments in a sample, the relative proportions of the segments in a sample are exactly the same as the proportion of segments in the population, we don't have the problems of over or underrepresentation. Okay? So, stratified sampling, what is cool about it is we don't just have to stratify based on one dimension. So, we could stratify a population based on gender. So, we have men and women. We could stratify sample a population based on based on party affiliation. So, we have 3 segments. But it turns out that we can stratify sample people based on multiple dimensions or features at the same time. So imagine that we want to stratify COMG measures both on the following 2 dimensions. First of all, we want to stratify COMG measures based on the gender, and then based on whether they're domestic students or international students. My question is, how many strata we should create? Okay, so I'll stop here with this question for you to ponder upon, and we'll continue and finish up the lecture on survey tomorrow. Okay? All right, see you tomorrow then.